Righty. Hello everyone, my name is Tim Galvin, and before I tell you about my PhD project, let me tell you something really interesting about the universe. It is inconceivably large. So large in fact that light, which travels at around about 300,000 kilometers per second, can take hundreds of millions or even billions of years to reach us here on Earth from the most distant objects in the universe. So with that in mind, you can sort of imagine that as we build bigger and bigger telescopes that are more and more sensitive, we are literally building a time machine that can take us into the past, much like Marty McFly and the DeLorean. With that said, one of the current unanswered questions in contemporary astrophysics is simply, what is the star formation history of the universe? And what I mean by that is, as galaxies go through the universe's life, do they always produce the same number of stars per year, or do they sort of build up to a peak before dwindling down to current day levels? With existing radio data, we have a pretty good handle on what we think that looks like, and that's the plot I show up on screen there. The red measurements show that around about 10 billion years ago, which corresponds to a redshift of about 2, galaxies were far more active than what they are today at a redshift of 0. Now, it may be hard to see, but at around about a redshift of 0, there is a single red mark, and there are no lines around that. And that means we are relatively certain that that is the correct measurement. The problem, though, is that at higher redshifts, or more distant objects, we're far less certain. Those large error bars are simply because of two reasons. The first is small number statistics, and the second is we're not really sure about the physics. Thankfully, though, in Western Australia, the next generation of radio telescopes are currently being built, which will be far more sensitive to the very distant objects in the volume of the universe that we are unsure about. My project has been looking at trying to understand the physics behind those objects. I have compiled a very comprehensive set of radio data from a collection of sources which are representative of what we expect to find in that early universe. Within a Bayesian framework, I have analysed the physics that drive the radio signatures of star formation, and I have learned to take the data from these telescopes and extract from there the signature and the rates of star formation across cosmic time. Once these telescopes are finished, they'll be producing terabytes of data every second. So it's important that we really understand the physics, because the small number statistics will no longer be a problem. If we understand the physics, then we can robustly characterize the star formation history through time. Thank you very much.